Fraction decomposition part 3. Today we're going to look at irreducible quadratics. So this is again going to be just a slight modification how we do the setup. Some of the algebra can be kind of a pain, like when we do this last problem. I mean, not terrible, but you'll see when we get there. But otherwise it's going to be very similar to the last two lessons. So let's start with this first example. Now remember, we are breaking up fractions. We are unadding fractions, decomposing fractions. And in order to do that, we have to see what denominators could this have come from, like, before it became a common denominator. And to see that, we're going to factor it. And those would be my two original factors that this would have come from if I break apart this into an addition problem. Notice that this is a quadratic and it cannot be factored, at least with like integers, right? So that's why we call it an irreducible quadratic, and it requires you to set it up just a little bit different. So I have no idea what the numerators are going to be, so that gets my A. Now instead of just putting a B right here, basically the deeper reason why is this needs to be a proper fraction. Let's go back to numbers for a minute. So if I have a bigger number on top than the bottom, that's like an improper fraction. And I can always divide that and make it like this is like 2 2/3, right? This is a proper fraction, and that cannot be kind of broken like this. This is a proper fraction, kind of means between 0 and 1 when you're talking about numbers. Basically, the idea is this has to be smaller than this in order for it to be a proper fraction. So we're going to extrapolate that into algebra. That means I could have a constant over a quadratic that's of lesser degree, but I could also have a linear function on top of a quadratic. That's still of lesser degree than the bottom. When we're dealing with polynomials, lesser degree would be equivalent to smaller, right? So this could be, oops, I already used A. This could be a linear polynomial up there. See, this was linear, so the top had to be a constant to get smaller than linear, first power, 0 power. This is a quadratic, so it could have just the x term up there, it could have just a constant term up there, or it could have both. As long as this is of smaller degree than that, that is fine. But if all that was very confusing, this is what you have to learn. If you have a quadratic here, you got to have an x term and a constant term, or else you're not going to get the right results. Okay, that is the only new thing, so now we're just going to do the problem as usual. So how do we do it? I need to get common denominators. I'm focused over here, so I'm going to multiply this by x plus 3 and this by x. And we understand, right, this is calculus, not algebra 2 or something. We understand that by doing that, we have common denominators. That was the whole point. So I'm not even going to bother writing that step. In algebra 2, I'd insist on it, but in calculus, we get it. So our focus is the numerators, and we understand why the denominators kind of drop out through logic. So this breaks down into this numerator has to end up equaling the sum of those two numerators, and we just got to distribute, right? Be a little careful up here. And that looks like what we have to deal with. So then from that we have to create our system. So we're going to have x squared equation, x equation, and constant equation. So we know that A plus B ends up equaling 6. And we know that C ends up equaling 3. That's nice. And we know that 3A ends up being 12. So this is actually a very simple system. We already know C is 3. With a flick of the wrist, so to speak, we know that A is 4. And if A is 4, then B must be 2. That was really easy. So we would state in our answer, this is equal to 4 over x plus 2x plus 3 over x squared plus 3. So if I were to add these fractions, I would get that result. I decompose the fraction. All right, so not too bad. Let's knock out a couple more examples just to make sure we got it locked in, and then I'll let you get to it. Example number 2. Ooh, I don't think that's supposed to be x to the 5th. Give me one moment. Yeah, that's x squared. I think I went a little 5 happy. My apologies. Right? It'd be trouble if that was a 5 because that would be a bigger degree than the bottom, and that's actually going to be our next lesson. All right, so if we want to break this down, we have to be able to factor the bottom. This is why in pre-calculus, you better be paying attention to factoring because it doesn't go away. How do I factor that? Well, if I look at it, that is a grouping problem. So I see that I could pull an x squared out of the first 2 terms. I'll do my factoring work in purple. And I can pull a 2 out of the next 2 terms. And I see that can be pulled out of both. And if I do that, I'd be left with x squared plus 2. So there's my factorization, and see, irreducible quadratic. So one of my fractions has to have this, and one has to have this. You know, now that I think about this, I don't think I mentioned, I'm going to erase this work here. It doesn't matter which, right? 3 plus 4 is the same as 4 plus 3. If you wrote the x minus 1 first and the x squared plus 2 second, it wouldn't make any difference. We'd have different stuff we called A, B, and C, but when we actually got our answer and wrote our answer down, we would have the same answer. It shouldn't matter when you add, and it doesn't matter when you add. So I'm just going to go with the first way I had it. That's a quadratic, so this could be linear, so I'm going to put ax plus b. That's linear, so all I need is like a number, so I'll call that C. And there's my setup. If I get how to set it up, the rest is all downhill. What do I do next? Well, I got to get that to the common denominator, so I'll multiply this by this, and this one by this one. I already know how the denominators will work out. That's the whole point, so we'll focus on the numerators. In video 1, I showed you why that's legal to do that. So this is ax squared. Let's do minus ax plus bx minus b plus cx squared plus 2c. All right, I see squareds, linears, and constants. So a plus c has to equal 1. And minus a plus b has to equal minus 5. Make sure that minus shows up, excuse me. And numerically, we'd have minus b plus 2c also equals minus 5. All right, there's my system. I'd have to do a little bit of work in this case, so you grab whichever 2 looks like it's easiest. Personally, I would grab the first 2. Let's call this step 1. A plus c is 1, minus a plus b is minus 5. I can add it the way I see it. Those drop out, and I get b plus c equals minus 4. See how that one has the same variables as the one I haven't used yet? So I'm going to pull those together in step 2. And nicely, I don't even have to tweak them. If I add these column-wise, the b's drop out as is. And I just got my first one, c equals minus 3. So I could call these steps if you want, but these are pretty simple equations. If c is minus 3, then a must be 4. And I like this equation better. If a is 4, then b must be minus 1. And that's all the things I had to solve for. All that remains is I just have to write my answer. So I'm out of space. I got to erase in the middle here. So this fraction can be decomposed into 4x minus 1 over x squared plus 2 added to minus 3. So I'm going to subtract 3 over x minus 1. And there would be my decomposition. All right, one more to go. It's a little messier. So I wanted to do some that had different kinds of factoring involved, just in case it was good to refresh your memory. Grouping is one that you don't do real often in the lower level classes, so because you don't hit it often, people tend to forget it or not look for it. Now that one, I call that quadratic in format. It's actually a quartic polynomial in the denominator, but I would factor it just like when I'm unfoiling a quadratic. So this is going to be x squared times x squared is x to the 4th. 9 times 4 is 36, and 9 minus 4 is 5. That's my combo. And I want the 9 to be minus and the 4 to be positive. Well, this is a reducible quadratic, difference of perfect squares, and that is an irreducible quadratic. So there's my factorization, and that tells me how I have to break this up. I have no idea what the numerators are at this point, so I'm going to call this A, that's linear, B, that's linear. This is quadratic, so this has to be cx plus d, 1 degree smaller than what I see in the bottom. Notice that this was 1 degree smaller than what I saw in the bottom. All right, so here comes the messy algebra. I have to multiply this one by x plus 3 and x squared plus 4. So I have to multiply this one by x to the 3rd plus 3x squared plus 4x plus 12, and that's a really bad marker. This one I have to multiply by x minus 3. This one's not any better because it's too light, I think. Let's go blue. So this is going to be times x cubed minus 3x squared plus 4x minus 12. And this one is going to be multiplied by x squared minus 9. And of course that's top and bottom. But we already know that the denominators are going to work out to be that. That's the whole point. So our focus is really on our numerators. Okay? So I have 3x cubed plus 24x squared plus 12x plus 57. Let's just be careful here. Ax cubed plus 3ax squared plus 4ax plus 12a. If we were in face-to-face class, I'd say if you catch me making an error, stop me. But no net here. So bx3 minus 3bx squared plus 4bx minus 12b plus cx cubed plus dx squared minus 9cx minus 9d. That's barely fitted in there. All right. So we have cubes, squareds, linears, and constants. And this could be very ugly, but we don't know yet. So let's just see what we have before we freak out. So let's start with the cubes. I see A plus B plus C has to equal 3. Okay. Squareds, 3A minus 3B. I don't see a C squared, so I have plus D equals 24. Linears, 4A plus 4B minus 9C equals 12. And constants, 12A minus 12B minus 9D is equal to 57. All right, this is a mess. This is the most complex system we've had to solve. I think at one point it might be worth having a little mini lesson to show you how to do this on a graphing calculator, but we're going to do it the old-fashioned way here. So what we want to do is we want to stop and think. When I look at this, I see that these two have the same variables, and I see that these two have the same variables. So this is complex enough you want to think before you do. Let me show you what I'm thinking, right, so you can see how I'm processing this before we actually jump in and start doing algebra. If I were to take these two, I could solve this one for C and then sub it into here, and that would give me A and B equation 1, let's call it. So by using these two equations, I could whittle those down to a new equation that only has A and B. Then, if I took this equation and If I took this equation and I solve for D, and then I sub into here, so if I solve this for D and substitute that right here, I would get A and B equation 2. So then I could put these two together, and I could solve for one or the other. Let's say I got A equals, then I could plug A into one of those and get B equals. Once I know A and B, I can plug them both into here and get C equals. And once I know A and B, I can plug them both into here and get D equals. Right? So part of moving into advanced mathematics is not just being good at the mechanics, which you got to be. You've also got to be able to step back and think about, how am I going to attack this? This is strategy. Look, I'm not solving anything here. This is how I'm going to attack that mess. If you just go in blind and start trying to solve stuff, who knows what rabbit trail you're going to go down. So this is very important. Stop and think before you do. All right, so now that I have a game plan, I'm going to erase this and I'm going to start doing it. So I'm going to erase that, and I'm going to number these equations. 1, 2, 3, and 4. That way I can refer to them. So I'm going to use equations 1 and 3. So to do that, let's see. I'm going to take this one, and I'm going to solve for C. C equals 3 minus A minus B. And then I'm going to plug that, see that's what C equals? I'm going to plug that in right there. So that's going to give me 4A plus 4B minus 9 times 3 minus A minus B equals 12. See how all I have are A's and B's? All I got to do is make that look nice. 4A plus 4B minus 27 plus 9A plus 9B is 12. 13A's plus 13B's equals 39. That's nice, right? I can divide everything by 13. So A plus B equals 3. I'm going to box that. See how I left off on 4? I'm going to call that equation 5 because I'm going to have so many equations rattling around here. It's helpful for me to have organizational benchmarks, right? This is a key place to end up. That wasn't an original equation, but it flowed out of 2 of them. All right, now I'm going to use equations 2 and 4. So I'm going to take this one and solve it for D. D equals 24 minus 3A plus 3B. And I'm going to take that and I'm going to put it right there. See, I'm just doing what I already figured out. Now you just got to work all the nuts and bolts into it. So there it is. Might need to bust out a calculator here. Let's see, this will be 180 and 36 is 216 plus 27 minus 27, 57. So I'm getting 39A minus 39B. My hopes are getting up here. This would be 273. Now let's see if I can divide 273 by 39. Yep, it equals 7. So if I divide everything by 39, I get 7. And that gives me equation number 6. Well, I'm going to have to do some erasing. So now I need to take equations 5 and 6 together and solve for, it looks like I'm going to be solving for A, right? So on a piece of paper, I just keep running it right down. I wouldn't be erasing stuff. So I'm going to pull these 2 equations together. I'm going to use equations 5 and 6. So these drop out, and I get 2A equals 10, A equals 5. Stop and enjoy that for a minute. That is a good feeling when you got all this work and you knock out your first one. So once I have A, it's all downhill from here. If A is 5, if I plug that into one of these equations, let's say here, then B is minus 2. And if B is minus 2 and A is 5, if I plug them in here, I would have 5 minus 2 plus C is 3. 3 plus C equals 3, so C's got to be 0. And if I take these 2, pick your favorite D equation, I like that one best, and I plug them in there, I would have 15 plus 6 plus D is 24. 21 plus D is 24, so D is 3. Let me put all that in one place. A is 5, B is minus 2, C is 0. D is 3. Well, now all I got to do is write my answer. So finally, I go back to my original breakdown. A is 5. B is negative 2. C is nothing and D is 3, so that would be 3 over x squared plus 4. See, that could be a linear, but it could also be a constant. You don't got to figure it out. The math will do it for you. All right, thus ends part 3 for fraction decomposition. One more to go. I'll let you play around with that.